Hello, my name is Todd Rothman, and I want to welcome you back to Organic Chemistry 1. In this video, we're going to learn about the nomenclature of alkanes. We're going to start by talking about straight chain alkanes, how to name them. Then we're going to go on to talk about branching alkanes, so more complicated branching. And then we're going to finalize by learning some common nomenclature to make it easy for us to name these complicated branches. Now, the first thing I want to mention is that there are two ways that we could name alkanes. Well, actually, it's more than two, but two that are very common to us to be familiar with. And that is, the first one is a very systematic approach. It's very organized, it's structured, and it makes a lot of sense, actually. It's much more approachable and universal for people to communicate about the same molecule. And that's called the IUPAC nomenclature system. Okay, and so what that is the International Union of Pure and Applied Chemistry. So what they have come up with is a set of rules that you can follow to name molecules, no matter how complex or simple they may be. Now, the second way is called the Common Nomenclature. Now, this is more, sometimes it's actually useful to go through Common Nomenclature, but this is more about not so much any kind of systematic approach. Well, sometimes they say that it's semi-systematic, so there might be some logic or some systematical approach to the naming, but a lot of times it's just named by random choice, like, for example, where something was discovered. So here's an example where I talk about formic acid, and formic acid comes from ants, and so formica is the Latin term for ant, and so that's where formic acid comes from. So as you can see, it doesn't necessarily have to have any logic to the name other than its origin in this case, okay? So that's what common nomenclature is. Now, through the years, the IUPAC nomenclature has adopted some of the common names because it becomes something that it's universally accepted as a IUPAC nomenclature, and we'll kind of see that as we go through this video and the next few. Okay, so let's get started. So we're going to primarily focus on the IUPAC nomenclature, just so keep that in mind. All right, now the first one is the unbranched, and this is really just all alkanes, right? We're looking at the alkane nomenclature. We'll learn about other nomenclature in other videos, but in this case, if you have 1 carbon all the way up to 10 carbons, you need to know their names, and it's just straight memorization. So 1 carbon is a methane. Notice how they all end with ane because it's an alkane, sp3 carbon with all single bonds. So eth is 2, prop, bute, pent, hex, hept, oct, non, and decane. Those are the ones that you need to know. You have to just memorize it. There's no trick here. Just memorize them. Okay? So 1 through 10. They usually don't ask you questions beyond 10. So you know your textbook usually goes up to like 50, and they kind of jump around. From after 10, they do 11, maybe 12, and then they start jumping. But you have to worry about the first 10. Okay, that's traditionally how most courses across any school, they require you to know the first 10. So keep that in mind. And so here are the first 10. This is the very simple nomenclature. Notice the pattern that these are all straight lines of carbon. So if I wanted to, let's say, condense this, which we saw in the previous video, an example of how to extract out a condensed formula, well, notice the pattern that all we're doing from, let's say, 3 carbon to 4 is adding an extra CH2. See that? So you have a CH3 on both ends, and then 1 CH2 for 3 carbons, 2 CH2s for 4 carbons, 3 CH2s for 5, and so on. So a way to write this is to say I have a CH3 on both ends, and then I have CH2 n number of times, right? That's how we can do this. So if we look at, like, for example, 5 carbons, well, we already have 2 of the 5 taken care of, so there's 3 CH2s. So we'd write 3, and that's the same thing as pentane, right? Drawing it straight out. So basically, it's 2 less. If I want 10 carbons in this formula, I write CH3, CH2 8 times CH3, and that equals 10 total carbons. So you see it's a lot easier to manage it that way. So keep in mind that you can condense the number of CH2s in the middle, provided it's only CH2, and in this, for this particular video, that's all it will be. Okay, so that's a straight chain. Again, just memorize methane all the way down to decane. You have to just know them, okay? Now, the next section is about branched nomenclature. So here's where it gets a little bit interesting. Now, if you have a straight chain of carbons and there's some branching, how do you name those branches? That's what this is all about. Now, the first thing I want to point out is the idea of a substituent. What is a substituent? Substituent is a branch off the parent. We call that straight chain the parent. And once we identify the parent, if there are branches off that parent, it doesn't have to be carbon, but in this chapter, or at least this video, it will be carbon, but those branches are called substituents, okay? So any branches off the parent chain is a substituent. Now, as far as alkane substituents, so just hydrocarbon substituents, well, the way that we name them is by removing the ane, A-N-E, like methane, and adding YL. So the YL tells me that this is a substituent, not the parent. Okay? So methane becomes methyl. Ethane becomes ethyl, and so on. Butyl, pentyl, propyl, I skipped propyl. So propyl, butyl, pentyl, hexyl, heptyl, octyl, nonal, decyl, or decyl. These are all substituents off of some parent. Now, another one that's easy enough to remember now, and actually halogens, their weight, their priority is no different than any other branch of a hydrocarbon. So we tend to learn them together. Well, halogens, the way that this works is that you remove the I-N-E, like fluorine, or bromine, or chlorine, or iodine, or iodine. Those, you remove the I-N-E and add O. So by adding an O, that makes it a substituent. So fluorine becomes fluoro. Chlorine is chloro. Bromine is bromo. Iodine is iodo. And that's your halogens that you have to worry about. So that's how it works. You just remove the I-N-E, add O. Very simple. These are substituents. So this is when they're not part of the parent. They are attached to the parent, but they're not included in the name of the parent. That's how we do this. All right. So now that we have our substituents down, let's talk about the rules, and then we're going to go over this in a step-by-step process. Okay, so here's the big picture. The big picture is you first have to find your carbon chain. So you're going to have this carbon system, and it might branch up or down or left or right, and you have this carbon chain, and you have to find it so you know the largest carbon chain as being the parent. Once you have the parent, you want to number the carbon chain. Now, the way you number it is strategic based upon the substituents. You want them in low numbers, so we'll see that soon. Once you number the parent chain and you determine and identify the substituents, then you put the name together, and we'll learn about the rules to do that. So this is a summary of what we're about to do. So let's get started. Now, the first step is to find the parent. And what I wrote here is that find the longest continuous chain. What does that mean? Well, you want to count a chain that starts from one end. You have to find a point, an end, and go all the way to the other side without let's say your pen, if you're tracing it, without your pen ever lifting up. It should be a continuous flow of carbons. So from one end to the other end. That's what you want to do. Now keep in mind that it might not be a straight line. It could be on an angle. As long as you start from one point and you end at the other point, that's a continuous chain, and it doesn't have to be a straight line. So let's take a look. Analyzing this right here, I see probably this right here is my continuous chain. Okay, now how do you know? Well, you count. Count the carbons from each point. So looking at this here, I have 1 carbon, 2 carbon. Now I can go up for 3 carbon, but that's much smaller, right? So 3 carbon, 4 carbon, 5. Now I might work down for 6 and 7, but here 6, 7, 8. Ah, that works. So that's 8. Now again, look at all your combinations. You just have to start from one point and end at another point. That's all you need to do. So I can start here and end there, or start on the left and end over here and end over